There are two engine-driven generators. The generators maintain a constant speed by a drive mechanism known as an integrated drive generator, IDG. Each generator supplies alternating current, AC, to its own bus. Each bus supplies its own transformer rectifier, TR. AC bus 1 to TR1, AC bus 2 to TR2. The TRs convert alternating current into direct current, DC, to supply their associated DC buses, DC1 and DC2. DC bus 1 then feeds the DC battery bus, labeled DC BAT. The DC battery bus can charge the batteries or receive power from the batteries as required. The electrical system also includes two essential buses. The first one is the AC essential bus, fed by AC bus 1, and the second one is the DC essential bus, fed by the DC battery bus. AC essential in turn powers the AC essential shed bus. DC essential powers the DC essential shed bus. They are referred to as shed buses because they are automatically shed should the electrical system be reduced to batteries only. This is the basic electrical system. The electrical network can also be supplied by the APU generator. These three generators are all identical, and any one of them can supply the entire aircraft's electrical needs. On the ground, the aircraft can be supplied by an external power source. The shed buses are not shown here simply to save space. As a backup, there is a hydraulically driven emergency electrical generator. Again, the shed buses are not shown, simply to reduce page clutter. The hydraulic power to drive the emergency generator is provided by a ram air turbine, RAT, located in the belly fairing, which extends in case of severe electrical or hydraulic failures. The electrical system is also fitted with an essential transformer rectifier. Now, let's see how this information is presented to the pilots in the cockpit. We will introduce the ECAM electric page. You can see that all the components we have talked about are displayed on the ECAM page. Notice that each component has a title to aid identification. Let's briefly review the basic system using the ECAM electric page. Generator 1 and Generator 2 supplying AC bus 1 and AC bus 2. TR1 and TR2 supplying DC bus 1 and DC bus 2. Two essential buses supplied by the left side. The DC battery bus and two batteries. Each component can be monitored via its indications. These indications are voltage, amperage, or load on the generators, frequency, IDG temperature, You can also notice that the different connections are displayed via green lines. Let's now locate the various controls available to the pilots and associate them with the components displayed on the ECAM. The electric panel is located on the overhead panel. For emergency cases, there is an emergency electric power panel on the left side of the overhead panel. Now let's look at the relationship between the electric panel and the ECAM electric page. The battery voltage can be monitored either on the overhead panel or the ECAM page. Each battery is controlled by a push-button switch. Both main generators and the APU generator are controlled by their associated push-button switch. The external power is also controlled by a push-button switch. The AC Essential Feed push-button switch enables the pilots to change the feed for the AC Essential bus from AC Bus 1 to AC Bus 2. The bus tie push-button switch allows the crew to isolate one side of the electrical system from the other. In case of failure, these switches enable you to disconnect an IDG from its drive shaft. The controls and indications on the emergency electric power panel will be covered in the abnormal operation modules. There is one exception. The emergency generator test switch is used by maintenance only to test the emergency generator.